Hey everyone, I hope you all are safe and doing good. So, in the previous lecture, we have seen four fundamental data types or primitive data types in Java, that is byte, short, intent, long. Now, we are left with four more data types, that is float, double, char, and boolean. So, those remaining data types, primitive data types, we'll be discussing in this lecture, right? What is float, double, char, and boolean? So let's first start with float data type. See, we deal with floating point numbers as well. It's not like that we always deal with the whole number, integer number, like 10, 1, 0, or any number 9800. No, we deal with floating point number as well. Those numbers are having fractional part. Like in when you are calculating your average or your marks, maybe like 98.99, something like this. So these are floating point number having a fractional part, right? In scientific calculation also we need floating point number. In financial calculation as well we deal with these numbers, like a price of something. In billing also we deal with fractional numbers, right? There is not always a whole number in every everywhere, right? So we have two data types as well, primitive data types in Java, and these data types deal with floating point number. We can represent these floating point number with those data type. What are those data type? One is float and one is double. Okay. Now the float, the size of this data type float is 32 bits, means 4 bytes in memory would be allocated. So if I write something like this, if I have like a variable of type float, suppose marks is equal to 98.9. What is this f? I'll tell you. So this is the variable. For this variable, how much memory would be allocated? 4 bytes would be allocated. 32 bits in memory, right? The range is approximately this for float data type. Minus 3.4 E 38 2 plus 3.4 E 38. Now this E is what? It's in scientific notation. Basically, when you represent E, it's like minus 3.4, that is into 10 raised to power whatever is there after E. So here 10 raised to power 38 only. Something like this. This is how we denote this number. So these are either very small number or large number having many zeros. So rather than writing so many zeros, maybe 10, 20, 30 zeros, in computer they denote it in this scientific notation having E, something like this, right? So this is the range. Now default value for float is always 0.0. It's f. See, at last we have written f. So to specify that it is a float number, the suffix we will add as f, small f, or capital F, right? Why we need to add suffix, that also I'll tell you. Now one more thing is there in floating point data type. Precision means after decimal, like 98.99. After decimal, how many decimal digits are there? So if a variable is float type, then after decimal it can store 6 to 7 decimal digits. In some uh, laptop you will see like some machine is 6. In some machines it will show till 7 decimal digits of precision. So like 9912345, something like this. So till 5. In float it will represent the number till 5. Because if floating point numbers, we cannot represent a floating point number accurately, because after this decimal there can be many numbers. Sometimes when you do something like this, 10 raised to 10 divided by 3, so it would be 3.3333333, something like this, infinity. So we cannot represent a floating point number accurately. So obviously this float and double are also not accurate one, right? But definitely these are more accurate than the whole numbers, right? And see, this is about float. Now I'll show you with example as well. Now the what about double data type? If we have a double, let me just show you that slide first. So this double data type occupies how much memory? 64-bit memory, means 8 bytes, this data type. So if I write something like this, like double, and if I write marks, same example I'm taking is equal to 98.9. And at last we write D, small d or capital D. And in float we write small f or capital F. So this is, I am specifying that this is a double. So this marks will take how many bits in memory? 64 bits, this variable. Default value is 0.0d, or default value for float is 0.0f. Now what is this default value? This default value would be assigned to instance variables only. This thing we have discussed when we were discussing types of variables. Instance variable, local variable, static variable. So instance variable or class level variables. Those variables only, if you don't initialize those variables, then the compiler will automatically assign some default value to those variables. But the default value would not be assigned to local variables. If you don't initialize a local variable, or if you declare a local variable and don't assign any value, and if you are using that local variable, then it will give error. So this default value is just for instance variables. In previous also case also, when we were discussing byte, short, int and long, the default value of all these four data types is 0, and that also will be for only instance variables, not for local variables, right? Range is this one, approximately 1.7 e. Now 10 raised to power 308. See how many zeros? 1.7 e, 10 raised to power 308. So this is range of double. Now after decimal in double, the precision point is 15 to 16 decimal digits. So after decimal we have almost 15 to 16 digits. So definitely this number would be more precise than a number which is having only 6 to 7 digits after decimal. Yes or no? I hope you are getting this point. So that's why if you need more precision, then we use double, because it is more precise than float, because of this reason also. It is having 15 to 16 decimal digits after decimal point, right? So that's why, because of this reason also, by default for floating point number in Java, the data type is double. By default it's double. So if you write something like this, if you write float f or float marks is equal to 98.9 and semicolon, what do you think? It will execute, or will it give error? It will give you error. I'll show you practically also. Why so? Because I have told you by default these floating point numbers would be considered as double. Now compiler will think that it is double, and here you are providing float. So it's wrong, right? Because Java is a statically typed language. So if you are providing float here data type, then here the number should be float. So you can write here F or capital F just to tell that, yeah, it is a float, not a double, right? So let me just show you these float and double with the help of some practical examples. So we are in our IntelliJ IDEA, and in the first project, here we have in the source, let's create a new Java file. And that is, we can say like, the name is floating point demo, or you can take any name, right? Let's take a first of all float variable, and suppose marks I'm taking equal to 98.99, right? See, you see the red line here? Provided is double, but required type is float. Means you have provided a double type here. So by default, the floating point number would be considered as double. So let's not remove this error first. Let's just display, make a function method here, that is display, and there We are just printing the marks, right? Have to print that thing, I guess, now, because we have used this thing many times. So after this display, I'll just within the same class, I'm writing, or let's create this time a different class, and let's make this class name float test. That's it. And here I are writing like public static void main. So to access the attributes or the members of this class, we have to create first object of the class. Name of the class is floating point demo. And suppose object is I'm taking obj is equal to new, and this is the constructor. Now with the help of obj, have to call the object name, dot operator, and whatever you want to access, marks or the method. I want to access display, the method. I just want to call this method. This is method calling. We will discuss about methods more, don't worry. So just the object, the method name, these brackets, round brackets and semicolon. So this is what calling. This is what definition of this method. We are defining what this method is doing, right? Now let's run this and see what output we are getting here. Okay, sorry, it's running integer demo. So here we have to run the current file, that is floating point demo.java. Possible lossy conversion from double to float. So from double to float. Okay, to float is fine, but where is double? So this is considered as double by default. Every floating number. So if you want to make, you have to make this specific. Like this is float, either capital F or small f. At this point of time, you will not get any error and this would be executed. Marks you will get here. So one point is this you need to take care. But if I write something like this, if I write simply 98, see at this point of time it will not give any error. Let's run this and I'll show you. It will print 98.0, right? So 98 is like it will automatically convert this into float. This is implicit conversion. 98 is like integer and this is float. So integer is small, float is more. So it will automatically convert this into float, right? Float is larger. So from smaller to larger, that there could be automatic conversion, right? That's why it is not giving any error. But if you write point 0.9 at that this point of time, it will consider it as double, and a double is large and float is small. So this conversion cannot be possible automatically. So one point is this. Now next point is if you can do something like this, like 9f, or I don't want to add f here. Now what is the second way to remove this error? You have to think and try this out. Don't just add here f. There's a second way also to convert this into float. And what is that way? Just pause the video and try this out. So I hope you have done this. The second way is what we can do is we can typecast this. You want to typecast this into float? So just write down in bracket here float. Now this is also fine. Let's run this and I'll show you the output here. It will give you 98.9. But rather than this, obviously we will follow. Just write down here f as a suffix. This is more, you can say, convenient to write, right? Now next is, let's take double, and in double I'm just writing suppose maybe any any number. Suppose I take a variable price and I'm just writing here price is this much only, and simply I'm printing price. So what do you think? It will give error or it will print whatever the price you have given? It will not give any error. See, because this is by default int literal, and it will convert to into double because this is smaller, this is larger. So smaller to larger is possible. So it will not give any error. if I write here 0.9, in that case also it will not give any error because by default floating points are considered as double, right? So you don't need to specify. Third way is you can write here D also or capital D also. So we are specifying that by this adding this suffix D that this is a double. But if you will not add D, that is also fine. But better to add. This would be recommended just to differentiate, right? So let's run this and it will show you both the float, the marks and the price. So this is some basic detail about float and double, how you can use them. Now next, if you use something like this, if I use like double and I'm using a variable like x is equal to, I'm writing here something like this, 1.7 and e and 308. This is what I'm using. This is the max range of this double, and we will just print this x. That's it. So let's see what output you are getting here. See, this is printing something like this, right? And if you write a number something like this, like 1.7, or if suppose I want to print this type of number, let's run this and see what output you are getting. So this has been represented by in this form, scientific notation form. So rather than representing so many zeros and all this number, better to use this scientific notation, right? So that's why the range of the float is given in this scientific notation, E notation. But you don't have to go into that much deep about mantissa and exponent, how to find out this magnitude and all. That is a different concept. You just remember the range of the float and just these simple things, how to write down, how to declare a float, a double variable and all. Now next thing is what? If I write something like this, see, if I write a number like float, number is like f is equal to 1.12345678910, 1 2 3 4, something like this, and semicolon, and it would be f. And now I want to print this f. So what do you think? What value will be printed? Let's save this and now let's run this. After decimal, see, it will print only after decimal, it will print only 7 digits, 7 decimal digits, right? So I told you the precision in float. After decimal, it will print 6 to 7 digits, right? So it is not, this number is not precise. And even after 6, we have 7, but it is 8, it is printing 8. So the number is rounded off. This is rounding because the next number is greater than 5. So this number becomes 7 becomes 8. So this is rounding, right? Now, if I take this float, sorry, if I take this one more variable, double and D, and same I'm, so this is the number I have in double, and same I'm printing this also, D also. So what do you think what it will print? Let's run this and see in both F and D what you are getting. See, after here we are getting only 7 decimal. Here we are getting after this up to 16 decimal. So 10, 11, 12, 13, 14, 15, 16. Up to 16 decimal point, right? So 1, 2, 3, 4, 5, and the 6 has been rounded off and it becomes 7. So the numbers are not accurate. Although the number is this, but we are printing in float this and the double is printing this only. So the number is not accurate. I mean, when you want more precise calculation, then we don't want to use float and double, right? Now in that case, there is one class in Java that is big decimal. So this is one class in Java that is big decimal. This is something like this, big and decimal. The name of the class is this. It's not this. Big and there is no space and D is capital and decimal. So this will be used when you are dealing with when you want to use in more precise calculation if you want to do, rather than using float and double. This will be later, we'll be discussing later, right? But see, the thing is, double is what? More precise than float. That's why by default we use double. So one assignment is for you. Now you have to convert whatever your height is in feet. It's 5, 5.3, 5.6, 5.8 or 6 in feet. You take your height in feet and convert that into meter, and then print that thing. So pause the video and try this out right now. So what you need to do is basically you have to convert feet into meters, and the formula is 1 feet is equal to 0.3048 meters. So what is your height? Suppose your height is 5.3 feet. So let's multiply this 0.3048 like this, and then you have to print, right? So take your height in feet. Let's take in like a variable, double variable, and then print the result. So pause the video and try this out. So I hope you have done this. Let's just remove everything from here, and let's take height. So we will take in double and a variable my height, and suppose I'm taking in feet something like 5.3. No need to write down here D or F, or obviously not F we'll write. If we write, we can write D here because it's double. Okay. Now you have to convert this into meter. So in display, we can have a variable like double, maybe result, and then result is equal to this whatever the height 5.3 into 0.3048. This is the case. Now semicolon. So don't need to put here this. If you want to put, you can just put here. But if you don't want to put these brackets, you can just leave it something like this. And simply just print here height in meters is whatever the result is. That's it. And we have called this here in this float test class. Now if I show you, let's just run this and let's see what output we are getting. So it's 1.6154, right? If you take this float, suppose f, and when you perform this operation, let's run this and see what output we are getting. See, the same thing we are getting here, right? So say in this program we have two classes, this and this. So basically you will get here in out, here you can see in production, first project. So see, basically there are two classes. So two dot class file would be there. So if you want to check, you can check out. So here I have in my PC users, in this user I have idea projects, and there I have first project, and there in source see we have floating point demo. So rather than source, we check out production first project, and see floating point demo dot class and float test dot class. So directly you can run from here also, from command prompt. If you want to run from command prompt, the one student was asking this question, that we write program in IDE and can we run in that command prompt? Yes, you can run in command prompt. Let me show you how you can run. Let's just open this in CMD command prompt. And my main method is in this class, float test. So you have to run this class, right? But first, directly if I run here Java C and float test dot Java, it will give error. See, file not found. Because the path is, see the path, it is searching in user, in this user, and that's it. But my file is within this user, then idea project, then first project, then out, then production, then first project. My file is here. Here, my dot class file is there. So you have to copy this complete path. Control C, and here we will be out from this path and we have only C drive. So CD and Control V, whatever the path you have. Now I can find, my compiler will find the .class file. So now I can run Java C and this. Okay, it's Java C. See, now error is again file not found because we are in out production. So here we have .class file. We don't have our Java file. So from here, if you want to run our Java file, then you have to come out. My Java file is here in src folder. So you want to compile this Java file, right? You want to compile that Java file, floating point demo, and the name of that Java file is floating point demo. It's not floating like that .class file. Let's just paste this, and I think we are done. We are in this first project now. Suppose I want to paste here this. Let's clear the screen. CLS. So we are in first project and src. So if I run my Java C, it's not, the name is not float test, the name is floating point and demo dot java. Now it will not give any error, right? Now suppose from here only we want to run, and the command is Java, and in which file we have main float test. So we have to run float test. Let's run this and see. Height in meter is this. You can run this from CMD also, but the thing is you have to set the path where you have your source file and then compile, and then you can just run that, right? But make sure, see now, the class name I am giving this, and for compiling I am providing this name because in this class I have my main. So definitely for JVM will run, entry point is main, so JVM will run this class only. You have to provide this class name, .class file name. Right. Okay. Now this is all about float and double. This is, I think you have done this thing also. Now let's discuss about character data type. So next data type is char data type. So this char data type occupies how many bytes? 2 bytes in memory, or 16 bits you can say, right? Now it is used basically to store a single character. Suppose I want to store this A. So yes, we can store A or 1 in single quote, and always we represent this in single quote, or a symbol like hash or space. This is space. So to store a single character we use char data type. Now it will take 2 bytes in memory. The range is 0 to 65535. Now see, there is no negative number. So char is represented in the memory as unsigned integer. Internally, obviously it is a character here, but internally it is represented as an integer, or more specifically if I say then unsigned integer. See, from 0 to, this is the range of character char data type. Default value for this is this, it is something like Unicode, and U stands for Unicode encoding. But let's just hold this point here. I'll discuss everything about this thing also, don't worry. Now this characters are stored as 16-bit Unicode characters. So what is this Unicode? I'll tell you, don't worry. Right. Now first of all, let me just tell you one thing about character. Internally, how to declare or define this? We write something like this, like char. This is the data type. Name of the variable, suppose I'm taking here grade, and your grade is suppose A. Now this A would be stored internally as an unsigned integer. Now why, maybe you are thinking, why 65,000 character or this range? Because generally we only see like alphabet A to Z, or A to Z small, or 1 to, or 0 to 9 numbers, and some special characters like hash, or special symbols, hash and all these kind of symbols. So why this much range, right? See, there are so many languages in the world. Japanese, French, or many languages, even in India, like Tamil, Telugu. And each language has its own character set, own symbols and characters. It's not like that we know only ABCD and in Hindi, these kind of things, and that's it. No, there are so many languages. Every languages have their different characters and symbols, right? That's why the range is this much, to represent all these characters from all the languages across the world in computer or in digital devices. That's why the range is this one, right? Now, I have told you internally the character is to be stored as integer. So, this mapping from a character to this integer, it is defined by Unicode character set. There is Unicode character set like ASCII. You have heard about ASCII character set, American Standard Code for Information Interchange. This is having small range, but there is a Unicode. This is international standard code. So Unicode, this basically contains standardized collection of all the characters, including letters, digits, symbols, control characters, or emojis, from all across the languages, from all the languages across the world. This character set. I'll show you this character set also, don't worry. Right? So these are some specifications. So now there are different implementation of these Unicode character set. You heard about UTF-8, UTF-16, UTF-32. Java use UTF-16 encoding scheme to convert character into that particular Unicode character set, Unicode character, right? Just to represent that thing in computer or digital devices. So Java uses this Unicode UTF-16 encoding scheme. In this, what will happen? Let me just show you. In this Unicode 16 encoding scheme, this is basically an encoding scheme which provides a unique number, or you can say it's a code point for every character, whether it's letter, digits, symbols, or another some special symbols or emojis. For every character, it provides a code point across different writing systems, symbols, emojis. Why so? Allowing for consistent representation and manipulation of text in computer and digital devices. Just to represent consistently all the character from all the languages across the world, all the symbols in computer and digital devices. Okay. So they provided encoding scheme. This is just an encoding scheme. UTF-8 is also there, UTF-32 is also there. Java use this scheme, Java language. Now, what is this code point? Every character is given a unique code, and the format is this: U plus XXXX. This XX, this is a hexadecimal number. For every character, this code is provided. This is a code point, right? Like, I'll tell you this, I'll show you this on my laptop, this Unicode and all. But just for suppose, for A, they provide this thing, U plus 00, I think it's 41. Maybe it's, I'm wrong, but we'll check this. But most probably for A, the scheme Unicode character is, encoding scheme is this 0041. The hexadecimal number is 0041. So whatever the character, that would be converted into this by the Unicode character set, or by this UTF encoding scheme into this. And then this would be converted into binary, like 0000. For 4, we like 0100, and for 1, it's 0001. So this is equivalent binary, and this is how to be stored in computer memory. So it's easy to convert this hexadecimal to binary, as you can see. This is to be stored in computer memory in binary form, obviously. And the decimal equivalent for this binary is, we know, that is 65. So when you print this, you get 65, right? So now this A, this can be represented by this A, by this literal A, by this encoding scheme, and we write this not like this, we write this something like this: slash small u 0041, something like this. This is what we can say, it's that backslash or character. So this is U for Unicode, and this is the hexadecimal form. Or this can be represented by the decimal number, that is 65. Right? So we can assign to a character to this literal also, a Unicode character set also, or this decimal also. How to initialize a character by in these three way, I'll show you with the help of practical. So in the source file, let's create a new Java class, and let's name it char demo. Right. And there we are taking a char character, suppose, and your grade is equal to A. And let's define a method here, display, and there we are just printing grade. We are printing this grade, and at this point of time, within the same class, I am writing public static void main. And let's create an object of this char demo, that is, suppose obj only is equal to new, and this char demo. This is the way we create object, and have to call the method obj dot display. Let's run this and see what output we are getting here. See, it is printing grade is A, because we have given here grade A. Now you can't write something like this, because there are two characters here. But with the char data type, you can store only single character. Too many characters in character literal. So this will not work. This will give you error. And if you remove these single quotes, this will also give error. See, cannot resolve symbol A. Means it, compiler is not able to identify what is this A. So you have to put single quote, right? You have to put here single quote. So rather than A, I can just write down here space as well. So if I print this, then it will print nothing. Just a space it will print, like there is a space. But if you don't write anything here, if you don't put any space, then also it will give you error. Empty character literal, that is not allowed. Or one also you can write down here. So this is also fine. Now one is a number, but this would be considered as a character because we are putting this in single quote. Now what? Next thing is any symbol also we can put, like I am printing here this at the rate. So this is also fine. This will print at the rate. See, right? Now, see, in Google, if you search Unicode table, and the first link is there. So once you click on this link, you will get here list of Unicode symbols, all the symbols. Just ignore these ads and see. The first is null, right? And Unicode for this is U plus 0000. So by default, character, the default value of character is this only. It will not print anything. If you want to go for A, see, the Unicode for capital A is U plus 0041. And if you want to search something more about this A, you can just click here and see. Unicode number is this, HTML code is this. So from here you can find out 65 is the decimal of this A. CSS code and some more information about this A. But we don't want to go for this information. We just want the Unicode. So there are so many symbols on this table. For 1, 2, 3, 4 also there is Unicode. 0031 is for 1. And there are many symbols as well. See, for every symbol you have some Unicode character, Unicode number, right? You can just scroll down and there would be many symbols here. For every symbol, see, for Hindi words also, it's U plus 0905. For Hindi words also, for these also, see. So you can check out for, there are many symbols. So if you are a Tamil or Telugu student, then also you can check out for your language also, there are many Unicode symbols and you can represent these symbols, right? Now, if I want to represent, see, I want to represent this, I want to write here the Unicode of A. So grade is equal to, how you write this slash, then U, small u, then 0041. This is how we can initialize a char with Unicode number also. It will print A only. Let's run this and I'll show you. Because this is Unicode for A. This is Unicode for A, character A, and it will print definitely A only. One more way is there. If I write here rather than Unicode, if I write here the decimal for A is 65. That will also work fine. Let's run this and I'll show you. It will give you A only. See. Because 65 is equivalent to in character A. So this will give you A only. Right? If you want to print something else, like if I want to print Unicode of, let's check the Unicode table, and I want to print K, this K. So this Unicode for this K is, it's 0958. So let's print this U 0958. So let's run this and see what output you are getting here. See, it will print K. So anything you can print, but this is invalid. If you write here capital U, this is invalid. You can't here write capital U. It should be, it's illegal escape character in character literal. It should be small u. It represents Unicode. And this is also illegal. You have to write down proper Unicode Unicode sequence. This is illegal Unicode escape sequence. So it's 5, 8, I guess. And if you want to print here like the maximum value 655, what is there? 65535. So this is the maximum value. Let's print this, and according to this value, what is there? It's nothing. So for 65535, it's printing nothing, or maybe the symbol, my editor is not going to support that symbol is there. Or you can check out what is the equivalent character for this 65535. So you can check out, we have chat GPT equivalent character for this. The value, this corresponds to the character. Okay, this one. This is a special character known as last character in the Unicode range. It's basically a non-character, so that's why it is printing something like this. Right? Okay, we have ChatGPT. Now you can ask from ChatGPT. And if I print something like this, suppose if I print here 65537, see, it will give you error. Provided is int and required is char. So it is considered this as int. But I want this to consider as character. So I can just typecast this. Now what it will print? Let's run this and I'll show you. I think it will print nothing. It will go for wraparound concept, but it will not print anything. Because in Unicode, after the maximum, we again go to here. After 65535, we go to 0, then 1, then 2, and something like this. And these symbols are nothing, they'll not print anything. But if you add something like, if you add here, suppose I want to print here 70. So let's run this and see what it will print. This is the char. So according to char, it will not give any error, although it is out of range of char, but it will go for the wraparound concept. Right? We have typecasted this into char, and this will print double quote symbol. So you can check out in this after 65535. it's 6553637 like this, 3839, and like this if you count, then this would be 65570. So that's why it is printing again 0023 this, or you can print here by 0023 as well rather than 70 by the encoding scheme, right? So this is how wraparound concept also comes in char as well. So same, if you didn't get that wraparound concept, let me just show you here. So this is for character. Here we have 0. So it would be 1, 2, 3, something like this. And there is no negative. So here we have 65535. 65534. Right? And once you go for 65536, once you add 1, then again it would be 0, then 2, then 3, then 4. Right? So for 70, it would be something like here, and for 70, it will print single quote. That sorry, double quote, right? And see, it is also fine if I write something like this: int x is equal to a, and if you print here x, what do you think? What it will print? Just pause the video and search. Try this out. If you print this x, then it will print here the integer value for this x, the decimal value, that is 65, right? Because characters are internally stored with the help of integer in form of unsigned integer. So there is data type is int, so it will convert this into 65, and 65 would be printed here. So I have told you we can assign a char in 3 ways. Like if I write char, or suppose I write here something like this, char, and char 1 variable name is a. Now if I write like char and char one more variable 2, that is 65, and one more char, that is ch3, is equal to with Unicode with U and 0041. So in this 3 way we can assign. So if you print char 1, char 2, char 3, what you will get? So we are printing all these 3 characters. So all these 3 characters will be printing A only. So you can initialize a char variable in 3 ways. Initializing with a char literal. This is the char literal. Initializing with an int literal. This is int literal. And initializing with a Unicode escape sequence. This is Unicode escape sequence. This is how you can do this thing. So now one assignment for you is you have to print minimum value and maximum value for a char type using wrapper class. There is a wrapper class for char, that is character. So use that wrapper class and print the minimum value and maximum value for char type. Pause the video and try this out right now. So I hope you have done this thing. Let's take a char, my char min value. This is the variable name is equal to, we are taking the class name is, see, the character dot min value. Same for maximum value, we have max value. So maybe you are thinking, let's just print now these 2 values. So let's just print, let's see. So I'm just printing my char first min value, and then in next I'm just printing my char max value, and we are calling this with the object. Let's run this and see you are getting output or not. See the symbols. I mean, nothing, null type of symbols it is printing. Why so? Because this min value would be something like some int value or something like this, like 0, or max value is 65535, and you are printing a character corresponding to that value. That's why it is printing the character, and the character corresponding to that value is corresponding to 0. The character is null, so nothing would be printed. Corresponding to that 65535 maximum value, the character is also not printable. That's why you are getting that output. But if you want to print the integer value, so how you can print that thing? Pause the video and you can just try this out. We have one method that is typecasting. I have told you, right? So we can typecast. Suppose I'm taking one variable a is equal to, and I will typecast this into int, whatever the my char min value. And same, I'm taking another variable b, and there I'm typecasting whatever the my character max value is. And rather than this, if I simply print, sorry, let's suppose we print this thing also, and we are printing both a and b also. So let's run this and see now this point of time what output you are getting here. So first two output are null and null, I mean nothing. Now next is 0 and 65535. So for that you have to convert this into int if you want to get that integer value, right? Now one assignment for you is you can try this out. You have to store a this symbol hash. You have to initialize this char variable. All the three methods you have to use with the char literal hash, with Unicode escape sequence for hash. You can find out, you have this table, and from there you can find out what is the escape sequence for this special symbol hash, or you can just ask from chat gpt and you can just use that symbol, right? And third is you use that int literal also, which is corresponding to the hash. So three character variable you have to define. You have to do this thing. So I hope character is clear to you guys. Now we'll discuss about boolean data type. So before going for the boolean data type, maybe you are thinking in char we are able to store only single character. So what is the use of this? Is there any special use, or is there really a practical use of using char data type? Yes, it is. Sometimes we have to process the strings or the file character by character in some applications. So there we use, you have to store a single character. So in there, this character data type will be useful. Now reading and writing individual characters in file operations also, right? So their character data type will be useful. Some encryption schemes are also there, some encryption algorithm there. You have heard about, you know about cryptography and all, or encryption and decryption. If you don't know, let me just tell you something about, see, in encryption, this is for if I want to send my this data char, so I will not directly send char, I will just encrypt this in another thing. Maybe I'm using some formula and all, and the c would be represented by like maybe x, this y, and this y maybe z or r by something else, right? Maybe s. So this symbol, this character, this message I will send, and the sender, I will send some key also, like I have applied this algorithm to convert this into this. And the sender will decrypt this using that key to char. So that in between, nobody is going to hack my message. Actual message is char, but I'm sending X, Y, Z as. So nobody is going to get this message. So this is what we do in encryption and decryption. There are some cryptographic algorithm also. So individual character would be substituted with a different character. So there we have to use the char data type to store a single character. So there, it's like there are many uses also for char data type. After ending of a game, you press any key, so that also would be stored in a character data type, right? So there are many uses for character data type as well. For character data type also. Now we have discussed character data type. Now we will see Boolean data type. So now there are two values on and off, or true or false, this logic values. So to store this logic value also, we have a Boolean data type in Java. We can store this true and false, these two logic values for on and off with Boolean data type. We can use true and false. Size is basically JVM dependent, but typically it's one bit of information. But we can't say it's JVM dependent. The size of Boolean data type. Default value is always false, right? And use is basically it's used for conditional statements and logic operations. When you want to check some conditions in control flow statements, in if else, we discuss if else later. If you want to check some condition, is it condition true or false, then we use this boolean data type, right? Or we can use these data types in decision making in programs. Same like if you want to make some decision, like if I ask you or some student, are you want to come in the class? Do you want to come in the class? Decision making in programs, like same like if else, if you want to make some decision based on some condition, the condition is true or false, then we use this boolean data type, right? Let me show you practically how you can use this thing. So in source, let's make a different class file and let's name it boolean demo, right? And there, let's just store how to write. There would be boolean, and suppose is java easy is equal to false, or is equal to suppose true. Yes, it's easy. So in display method, I'm just printing the value of this variable is java easy. And then obviously to call this, you have to create object of this class. And how to create, we know this is the method, and to call this, we write down obj dot display. Let's run this and see what output you are getting here. So see, it's true, right? And if you don't initialize this, then by default the value of this variable would be it's false. But it is the by default value would be assigned to the instance variables only, and we know this is instance variable, this is not local variable. If I declare a variable here like boolean is programming easy or programming fun, and I don't initialize this variable here, and suppose I want to print this variable also, is programming fun. So this, see the error, variable is programming fun might not have been initialized. You are using this variable, you haven't initialized this. So the default value would not be provided to this local variable. This is local variable because this is within this method only. This is instance variable because this is in class outside of any method. So these are class level variable. Only class level variables are getting default values. And it is true in all the cases, like whether it's int or it's you can say that byte or short or long or float or double or char, right? See, let me show you the default values here. Default values for data type is given here. For byte, short, int, long, it's 00. For long, it's 0L. For float, it's 0.0 F. For double, it's this. For char, it's null, this. Okay, string, let's leave it. And for boolean, it's false. But this value is for instance variables only, right? It is from that Java SC documentation only, from oracle.com official website. See, they have specified this. Local variables are slightly different. The compiler never assigns a default value to an uninitialized local variable. Right? Accessing an uninitialized local variable will result in compile time error. So this is true for only instance variables. You got it? So that's why you are getting an error here. So you have to initialize this. It's like maybe false. Now you will get the output. One is true, one is false. Right? So this is mainly used in control flow statements or conditional statements, where you are using if else and for loop also. There we will be using this. So we'll discuss if else for loop later. And in expression also we can use this boolean data type to control the flow of the program based on some condition, right? So now let me just give you one simple example, example here. Let's just comment out these all these things. Here I take two variables. Suppose I take int a is equal to 5, and or within same line also I can declare comma b is equal to, within same line also you can declare multiple variables, but that should be of same type int. So a is equal to 5, b is equal to 6. No need to write down here again int, otherwise it will give error. So simply this thing. But it's not like that b is equal to 6.7. This is float double, this is int. This is not allowed. Same data type is allowed. And if I write something like this, like boolean result is equal to a less than b, some kind of expression is there, although it's not like logical type of thing, but still, just to tell you, just to show you how boolean variables or can be used in an expression. So a less than b. So this, the result would be evaluated. A is 5, b is 6. So less than b, it's operator, relational operator. We'll see operator in next video. So 5 less than 6, yes, it's true. So in result we have true, right? Now you can simply print the result here. Is a less than b, and we can simply access the result variable. So let's run this and see. It's true. So boolean variables are used in this case also. You can store the result of an expression and later you can use that result to test some condition. Right. So boolean variables are this much only. We don't have much in these boolean variables. I hope you got this thing. So you can see here the same example whatever we have taken. Boolean, the name of the variable is Java fun, it's true, and there is two boolean variable. Now in conditional statements, this is how we can use boolean variables. Don't worry, we'll discuss if else later. If just the name of the variable is Java fun and the value is true, so the condition is true, so it will print enjoy coding. Now in logical operation also we can use, now boolean, see, as result is a variable, is Java fun, and this is logical and operator, and this is not operator, logical not, is programming hard. So is Java fun, it's true, the value is true, and not is programming hard, is programming hard is false, and not means it becomes true. So true and true becomes true, so it will print the result that is true. We'll see these operators in next video, don't worry. Right, if you're not getting this thing, leave it. So when to use boolean data types, this thing also I've told you, indicating the state of a condition or a feature. If you want to check any validation on an input, like if you input this certain thing and if you want to check this, if input is less than, like I have input 5 and I want to check this input is like less than or greater than something, the some value, like suppose less than 10 or not. I have entered 5 and I want to check this 5 is less than 10 or not. Input is valid or not based on some certain criteria. In control flow also we use this thing. In comparison also we can use storing result of comparison for later use. That thing I have shown you here. Right? Now, okay, now this is what the complete table we have: float, double, char and boolean. So this thing we have already discussed. Now, how to use the right data type? You have to identify the data. Now, you have to determine the which type of data you are working. According to that, choose the data type. Consider the range also. In which range, whether you want to work on a small data or on a large data. So based on that, you have to choose appropriate data type. Precision requirement. If you want more precise thing, more precise calculation, according to that, choose double. If less precise, you can use float as well, right? Memory constraint also. Consider memory use, especially for large data set. Like if you have constraint on memory, if you have less memories, then better to use those short data types. But if you don't have any constraint on memory, like nowadays in our system we have, a large memory, we don't have such constraint, so we don't care much about data type, right? Like even if store for a simple variable 5, we use int. We can use byte as well, but we use int, right? Now, okay, there are some pitfalls with primitive data types, with especially floating point precision. So when you use some arithmetic operation, when you do some arithmetic operation on floating point, then it will not give you exact values. It will give you some approximate values, right? So this thing you need to take care. Now, overflow, underflow, I have already discussed, right? Char versus string confusion. Char basically is store single character, In string is basically, you can say there are many characters, and string is in double quotes. So you have to, about string we will discuss later, right? So best practices for using primitive data types is what? You have to use appropriate file. According to your data, appropriate type you have to use so that memory wastage would be minimum. Consistent naming, the name of the variables should be descriptive and clear, and you can use constant for frequently used and important values, like for pi or max value you frequently use. So make that constant using final keyword and use that, right? So I guess you are now clear with the data types, primitive data types, all the 8 primitive data types. So based on this, you can now practice about this, whatever we have discussed. I'll give you assignment as well as quiz, right? So you can practice those questions as well. So now that's it for this video. Now I'll see you in the next video. Till then, bye bye. Take care.